is any variance in the given data set, maybe in terms of range, quartile deviation, mean deviation, variance, and standard deviation. And we have seen some certain relative measures also, which simply compares with the average values of this range, quartile deviation, mean deviation, variance, like that. Okay. So after that, we'll see something called as normal probability curve. And in addition to that, we are going to see what is a skewness and what is the actual meaning of skewness, what are the types of skewness, and what are the interpretations with the help of skewness. Next, we'll see what is kurtosis. Maybe some people call it as kurtosis also. So kurtosis, and what are the types of kurtosis that we can see, and what are the interpretations with that one. If you see, there is a difference between Japanese management and American management. Since majority of, like, almost all of your faculties, you might have come across the difference between these Japan as well as United States. So which is considered to be more quality oriented, either Japan or US? Which one is more quality, either Japan or US? Any guess?
I think Japan, sir.
Quality of things, sir.
Quality of the products. Quality of the products.
Wise, sir, it is Japan.
Japan. Okay, so now I have written, I have just plotted two curves here. So one is a red line, one is the blue line. So based on that, definitely sir will be able to answer. Even you will be able to answer. So in these, between these two, which one has got more quality? Either blue curve has more quality or red curve will have more quality. The quality will be ascertained with the help of the spread of the data. If you see the blue curve, so the range or something is coming from this to this. Okay, coming to the red curve, red line, which has got somewhat inner thing. Okay, so, and if you see, there is some kind of peakedness for red curve, which is somewhat flat in terms of blue curve. Okay, so there are different studies which have been done, like wherein Japanese used to use this red curve because the dispersion will be somewhat less when compared to the other country, even a developed country like US. Okay, and so that will be identified with the help of kurtosis. So that is major use of kurtosis, and we have got three categories of kurtosis. Okay, so once we see how to calculate something like that, then we are going to see that one. And last one is area estimation. So how many things, if it is a mean or the central value, so how much area is covered with these things, how much area is covered in this, how much area is covered in this, something like that. So these are the things that we are going to see in this module. Okay, so now we'll see some basics of that, which is called as normal distribution. So can anyone tell why the curve, like this sort of curve, is called as normal curve? Because I just want this session to be somewhat interactive. That's what, nothing more than that. It's not testing your knowledge, but I just want you to participate in the discussion. That's what. Why this curve is called as normal curve?
So because maximum of the data falls within the central part of the thing, within the mean. So
okay. So if you just see this one, so this is mean, and maximum of data, like 68% of the data is falling in this range. Okay, so from mean, if you just see mean minus 1 sigma, mean plus 1 sigma. What do you mean by sigma here?
Sigma is the variance, sir. That is
Is it variance?
Standard deviation, sir.
standard deviation. Standard deviation.
It is simply standard deviation. Okay, so for any data distribution, first we try to calculate the central tendency values and most probably mean. Okay, so though median is considered to be the best among these three in different perspectives, but majority of the people feel a mean is somewhat easy for calculation and most of the people use that one. And control limits and specification limits are also defined with the help of mean. Okay, and in that case, for each and every data, there will be certain mean value or central tendency value. Once we identify central tendency value, we try to identify how the data is spread. So that spreading of the data will be known with the help of standard deviation. Okay, and from mean, if you just add 1 into standard deviation, there is some distance. Okay, from mean, if you deduct 1 standard deviation, the distance will be something. And if the total points are lying in these things, then we can consider that process is good. Okay, and most of the times 68%, 68.26% of the data will be falling in that one. And there are certain natural phenomena like marks, height, and certain aspects will follow this particular distribution because these are natural in nature. Okay, so that's why this thing is called as normal distribution. If there is any deviation, then when we call it as not normal, we cannot simply call it as abnormal, but something which is not normal. Okay, so that is the thing. And coming to this -2 deviations. Okay, so if you just see what exactly is the spread of the data from mean value -2 sigma and +2 sigma, 2 standard deviations plus or minus mean value. If you just consider that value, 95% of the data will fall into that category. Okay, so 95% of the data points will usually fall into that category if it is a normal curve. Okay, if there is any abnormality or not normality, then we cannot expect this sort of thing. And if you consider ±3 sigma, if you consider ±3 sigma, so then 99.73% of the data points will fall into that range. Okay, still there is something 0.27 data which is missing. So there is some 0.27 which is missing, but mostly that can be considered some kind of error like thing. Okay, and this normal distribution is also called as Gaussian distribution because this has been named after a person, Frederick Gauss. So normal distribution has been named. There are a lot of historic aspects which happened for identification of normal probability or normal distribution, but major work has been done by this Gauss, so Frederick Gauss. So it has been renamed as other name has been given as Gaussian distribution. Okay, and this will usually create a curve called as a bell curve. If you see, the curve is like this, so it is increasing, coming down. It resembles a bell, so that's why it is considered as a bell curve. Okay, and there are certain properties for normal distribution. So that is, normal distribution curve is symmetric about mean. So what do you mean by symmetric in nature? Because I hope you know meaning of mean. Now they have mentioned something. Yeah,
into 2 equal halves. If you fold that thing, it will cover each other.
Okay, so it divides the total data into 2 equal halves. So 50% this side, if you consider, so if this is mean, so 50% of the data will be lying this side and 50% of the data will be lying this side. So that is why it is called as symmetric in nature. If that is not symmetric, there are certain curves like, so it will be like that. If you see, there is some kind of more spread here. Similarly, if you see something called as more spread here, so this is not equally dividing the data into 2 equal halves. So maybe this side is more, or in this case, this side is more when you take the mean value or central value. So these are called as asymmetric in nature. So this have given, this has led to the concept of skewness. So that we'll see in the next coming slides. And normal distribution is unimodal in nature. So this means it will have a single peak value. Yeah, just unimodal means just one mode or one peak value. So you'll not see multiple peak values like this. If you see certain observations, so this sort of things, if you see there are two peaks here, so that sort of peaks will not be observed with normal curve. Okay, so that it comes into some other category. And normal curve is always bell-shaped. We have seen that. And very important thing, if it is a normal distribution, so whatever the central tendency values that we have seen, like mean, median, and mode, will be exactly equal. So that is considered to be a normal curve. Is that clear? I hope you know what is mean, what is median, what is mode. So all the three central tendency values will be exactly same for a normal distribution curve or normal curve. Okay. If that is not same, then we cannot consider it as a normal distribution or normal curve. Right. And only examples of normal distribution. So as I have already mentioned, it is quite natural, like marks or scored by students in test follows a normal distribution. Usually, since every one of you is a faculty, so you might be conducting a test, and assume that for 100 marks, there are certain students who will be getting less than 10 or less than 20. There are some students will be getting more than 80, and majority of the students fall in between these things. So if you see, this is a natural phenomena where maximum of the students will be average marks getters or average scorers. And there will be some exceptional students who will not score or who will not appear and who will not get good marks. There are very few students will be getting 90% or 80%. So this usually follows a normal distribution. So have included certain examples. So based on that, we'll see how a normal plot will be, normal curve will be plotted. Okay. And heights of different people also follows normal distribution. Okay. If you see, most of the people, like if you consider adults, okay, so greater than more than 20 or something, most of the people fall in between 5 and 6 feet. Most of the people, okay, there will be very rare people who will be less than 5 feet. There will be somewhat very rare people who will be more than 6 feet or 7 feet. Okay, and maximum of the people will be falling in this particular range only. So that's why, as it is a natural phenomena, it is quite normal. And adults, like after beyond 20 years, like greater than 20 years, if you are less than 5 feet, it is somewhat abnormality. Okay, and similarly, if you are more than 6 or 7, definitely it shows some kind of abnormality only. Okay, and size of the objects produced by machine can also be arranged in the form of normal distribution. If you see, what will be the usual size of a laptop screen? Usual size of a laptop screen?
15 inches.
15.4 or 16.4 something. So 15 inches, 15.5 something. So there are certain things which are less than 14 inches also, but the number of products which they are putting will be very less. And similarly, there are certain things which are greater than 16, which also will be somewhat very less. So even if you just create manufacturing if you take any machine, if you see average, like, so 10 inches product, so mostly they'll have certain things called as 10 plus or minus 0.2. So that means they will assume that the products will be produced in between 9.8 and 10.2. So this is what their usual range of production, because you cannot exactly get 100, so 10 exactly all the times. There will be a certain deviation. So that is called as this one. Okay. So, and normal human blood pressure. So what is a normal human blood pressure? If you just consider as a single curve, so there is something called as 80. There is something called as 120. So 120 by 80 or 80 by 120, this is considered as a normal blood pressure of any person. Suppose if this is greater than 120 or 140, what is that position called as?
Hypertension.
Hypertension.
Yeah, high BP or high blood pressure. So that is not normal, which it should be treated. And assume that if it is less than 70 BP, so then it is called as
High.
some kind of
Hypotension.
hypertension. But yeah, hypotension and low blood pressure. So this also should be treated. So this shows some kind of abnormality or not normal. Maybe that person is not, the blood pressure of that person is not normal. So this is what the basic normal distribution. Okay, so the name has been given as normal distribution because it follows certain natural phenomena. If there is something different, so then we can call it as not normal. Okay, so we cannot simply call it as abnormal, but it is not normal. And coming to the history of this normal distribution, this has been given by first in 1753 something, in that time period, Abraham D. Moivre. So this person has started the concept of this normal distribution. Okay, and later in 1809, Laplace has introduced central limit theorem. I hope you have come across what is a central limit theorem. But it states that when sample size of random variable increases up to a certain extent or continuously, the distribution of the sample will approach a normal distribution regardless of underlying distribution of the original variable. Okay, are you clear with this central limit theorem? Central limit theorem states that when your data or the number of observations increases over a certain period, or if it increases continuously, it approaches a normal distribution irrespective of the original variable value or original distribution. So that is what central limit theorem. And central limit theorem is considered as a base for normal distribution. So taking this as base, so Frederick Gauss has introduced normal probability. And even he has taken the help of students' marks only to define the distribution and aspects of normal distribution. Is that clear? So this is what just historic background of normal distribution. Okay, and central limit theorem has major prominence for the normal distribution. And coming to the normal distribution, so usually the notation for normal distribution is mu, comma, this one, standard deviation, sorry, variance. So this is mean and this is variance. Okay, and this is usually represented as 0, 1. So remember this very seriously, like always mean of any normal distribution is going to be 0. Okay, and variance will be always 1. Obviously, standard deviation also will be equal to 1. Okay, so this is what the usual notation of a normal distribution, because here you have seen something called as binomial random variable, and even there is something called as binomial distribution that we'll see in a later class. Is that fine? Normal distribution, mu and variance, which usually represented as n0, 1. Okay, and coming to the skewness and kurtosis, as I have already mentioned about two terms. 0 skewness and kurtosis will be almost equal to 3. If that is the case, then we call it as a normal distribution. And we'll see what is the skewness and how this skewness and kurtosis will be calculated in the next slides. Okay, for time being, just assume that for a normal distribution, skewness will be always 0 and kurtosis will be almost equal to 3. Okay. And coming to the normal distribution is symmetric. As you said, it divides the total data into exact 2 halves. Okay, and most naturally occurring phenomena tend to a normal distribution. So that's why, since it is naturally occurring phenomena, then that is the reason why it has been in this normal distribution. Okay, guys, is that clear or any doubts? Is that clear or any doubts? Yeah. So now if you see the spread of the data, so as I already told that the spread of the data, I told for normal distribution, mean is going to be always 0. So in all the three curves, it is 0, 0, 0. And plus 1 sigma and minus 1 sigma. So this comprises 68% of the data. And if you try to do with the operation with plus or minus 2 standard deviation, almost 95% of the data will be coming to this slot. If you see plus or minus 3 additions of standard deviation, 99.7% of the data will be falling in that range. So though there is something of 30% or 0.23% of the data will not be falling. So this, because of this thing only, it is also called as 68, 95, 99.7 rule. So normal distribution always follows this particular rule. Okay, fine. So now if you see the frequency, if the frequencies are distributed on both sides of central value, then we call it as a symmetrical distribution. So how it will be there? If you see this one, so mu minus 1 standard deviation and mu plus 1 standard deviation. So this is what 68% of the data will be coming to this one. So this is just explanation or extension for the earlier slide. Okay, so now you see the total 50% of the data will be on the right side. Out of the total, 50% of the data will be on right side and 50% of the data will be in left side. Okay, so and if you just add for mu mean value, if you just add minus sigma and plus sigma, 68% of the data will be covering. And if you see plus or minus 2 sigma, so it covers 95% of the data. So 95% of the data will be covered with this particular thing. Okay, and if you just add minus sigma, minus 3 sigma plus 3 sigma for the mean, your 99% of the data will be falling into that category. Is that clear? Guys, is that clear?
Yes, sir.
Fine. Now we'll just see a simple example like how the normal distribution will be calculated, or the normal curve will be calculated. If you see, there is a bulb manufacturing company which has produced the below number of bulbs in the last 7 days. And we have to just find out the normal distribution curve using the details. And Monday, the company has produced 216. The second day, the company has produced 210. Third day, the Wednesday, it has produced 222. The fourth day, it has produced 212. Fifth day, it has produced 214. Sixth day, it has produced 220. Seventh day, it has produced 218. Okay, so if you try to just plot that Monday, Tuesday, Wednesday, Thursday, like that. So first, assume it is 260. Next, it has come down 210. Next, it has increased to 222. Next, it has come down drastically. It has become 212. Next, it has slightly increased to 214. Next, increased to a lot. And next, again, it has come down. So this is what the spread of the data. So is it a normal curve?
No.
We have seen certain, it is not normal. So we have seen certain properties of normal curve in which we have mentioned something called as normal curve is unimodal. That means only one mode it will be there, one peak. But if you see here, there is one peak here, even you can start from here. So there is something here. So how can you consider this as normal data? So for that, we have to see the normal distribution curve. I'll show that in an Excel thing. Okay. So the data which I've just shown. Now I think you can see my data, right? The data is in Excel and this also is that. Okay. So now I'm just going to copy this and paste here. So I've just got my data here. So how can we make it as a normal curve? So maybe some of you might have already come across this thing, but I'm just trying to plot that as a normal curve. Okay, so these are the things. For normal curve, what are the two parameters that we have seen so far? I have just told normal curve is having mean and variance or standard deviation. Okay, so this is what the parameters. So how can I find out mean here? Because I hope you have already seen what is mean, how to calculate mean, what is variance, how to calculate variance. So how can I calculate mean and variance here?
Sum of this divided by 7.
Okay, so sum of the values is alt equal to okay, so this is what my sum of observations. Okay, so if I want to find out mean, so sum of the observations divided by how many number of observations. So things. So it is going to be 216. So this is what my mean. So now I got my mean value. So now I need to find out the standard deviation. Okay, so how can I find out standard deviation?
You have to calculate, subtract each individual number with the mean,
Okay,
and then you have to take square of that,
okay, nice,
and then add all the square of that
fine.
divided by
Number of observations and square root. So that will give me standard deviation. So if I just want to find out this, the deviation, this is my observation minus my mean. Since I want to find out the difference, all the differences along with the mean, so I have just used that reference. Okay, so it is first 0. And if I just drag this one, it has given me these things. Okay, and as some of your friends have told that I need to find out square for that. Okay, so this is what my square. If I just drag this till the last, I'll be getting some value. So I want to find out the sum of these observations. Okay, if I want to find out the variance, so variance is equal to the sum value divided by number of observations. So 1, 2, 3, 4, 5, 6, 7 observations. So this has given me the variance. And standard deviation is simply square root of my variance. So this is what my value. Okay. So standard deviation also I got. So whatever the value which I got here, I'll be simply just making this value. Okay. Now I got my parameters. So these are called as parameters. I need mean and I need variance, and especially for plotting normal curve, they use standard deviation. So I got my two parameters. Okay. And coming to this particular plotting of this value, first we have to arrange that in a order. So mostly ascending order or a descending order. Okay. So if we just use this data filter and I want to arrange this smallest to largest. Okay. Guys, if you are okay with this space, I'll continue with this. Otherwise, I'll be making somewhat slow. Can I just consider this space is okay for you? Or anyone has got any doubt? This is sorted values, that's all. Because we have already seen what is mean, what is median, what is mode, and what is variance standard deviation. That's what I'm going somewhat fast. By assuming that you're quite okay with this one. And even the assignment which I have given contains similar kind of problems only. Okay, is this space fine or any problem? If I'm not getting answers, I don't know what should I assume.
I think it's fine, sir.
It's fine. Okay, so thank you. And that's what, like, since it is some kind of application of Excel or tool, some of you might be familiar, some of you might not be familiar. And if you feel I'm going a bit fast, you can just call me so that I try to slow down. Okay, and you need to find out the normal distance. So for that, there is a function called as norm norm distance. And this particular value. Okay, so what is the observation? So observation is 210 here. And what is my mean? I calculated mean as 216. So that should be given. And I have to fix that one. Okay, so why I'm fixing mean and the standard deviation, I'll tell later. So, and next, the parameter which is asking for asking by the Excel is standard deviation. As we have already calculated standard deviation, I am using that one and fixing that value also. And cumulative, there are two things like true and false. Since we are trying to find out probability mass function, we are not going to find out cumulative value. So you have to use a 0 for that. Okay, so if you use that 0, it will consider it as false and it will give certain value. Okay, so is everyone clear with the aspect which I have found out?
Sir, could you
Yeah.
please repeat it once again? How
Fine.
do you
Yeah.
do you fix it? That also you tell.
Okay, fine. So I want to find out the normal distance for that norm.dist. So that is a function. I'm taking that one and I'm using the first variable. So 210 is the first observation. I have to compare this variable with my mean and standard deviation, because in normal curve deals with mu and standard deviation, mu plus sigma, mu minus sigma, mu plus 2 sigma, mu minus 2 sigma, mu plus 3 sigma, mu minus 3 sigma. For that, I need to find out the normal distance. Okay, come on. And I'm using the mean, because when you type norm dist, it will ask for 4 parameters. First parameter is the output which you have got on one day, and the second parameter is mean. After selecting the mean, I'm using function value and F4. Okay, or you can manually type $D $14 also. So you can type manually $D $14, or you can use function with F4. Okay, so then I have to calculate, I have to use standard deviation. For standard deviation also, I'll be just fixing that reference, like because I have to compare 210, I have to compare 212, I have to compare 214, I have to compare 216, 218, 220, 222 with the mean. So, okay, so I have fixed both mean as well as standard deviation. And as I said, we are not going to find out cumulative value. So you just type 0. It will consider it as false and just close that one. So it gives me a distance, like, so as I told, for normal distribution, mean will be considered as 0, standard deviation will be considered as 1. So this is what my basic assumption. Okay, now if I see 210 is 0.03 times distant when the mean is assumed to be 0. So this 0.03 tells that, so this is the distance from mean 0 when it is converted into the mean value. Okay, and same thing, if you just drag that to second value, it has given 0.06. When we compare with that 0 mean, it's a central value, it is this much distant from that one. When you just drag this to the last, we'll be getting certain values. Okay, almost, since this is completely symmetrical, because I have taken first example very simple, so that if you just see, this is 6 away from the mean value, this is 4 away from the mean value, this is 2 away from the mean value, this is mean value itself, this is 2 away from the mean value, 4 away from the mean value, 6 away from the mean value. So as I have taken completely a symmetrical curve, it will be completely same as the observation. Now I have to just create a normal curve using these values. Okay, so if we just take this value and insert a graph, so if we use this particular scatter plot, okay, and use a curve like this. Okay, so if you just see that one, so this is what a normal curve for my present data. Is that clear? Then if you want to see data labels, you can see that data labels also. Okay, this is how the normal curve will be plotted with the given data. Is that fine? Now if you see mean is 216, with this 216, I'm just taking 1 minute. So as this is the mean 216, the first point is this much, second point is this much, third point is this much. Similarly, -2, -4, -6. As I've converted that into this value, the curves have become like that. Okay, so this is how we'll be plotting a normal curve with the given data. Is that clear?
Yes, sir.
Okay, so I've got 3 examples so that you can just see, like, as I've started the concept with telling there is a bulb manufacturing company, so it has produced different bulbs in the last 7 days. We have to see whether this distribution or the production distribution is following a normal distribution or not. For that, as first I found sum. So using that, I found the average, which is nothing but mean. Okay, so sum of observations divided by number of observations is that one. And I found out the standard deviation. So as I'll be sharing that Excel sheet with you, straight away you can find out standard deviation, or you can find standard deviation using formula also. Okay, so using that, I found out the normal distance between this production and mean. So that day's production and mean. Second day production and mean, third day production, that means. So fourth day production mean, fourth day production means something like that. So once it is done, I have got a curve like this. Okay. So this is what my observations. As here I have taken number of observations, first observation, second, fourth, fifth, something, 7 observations. So this is some kind of a normal curve. Is that clear, guys? So I'm assuming it is clear, right?
Yes, sir, it is.
Fine. So in this case, as I told, the marks obtained by the students also follows a normal distribution. Okay. So we'll see whether that is right or wrong. So there are 14 students, A, B, C, D, something like that. So you can name any students. Now we have to find out mean, median, mode, and of the percentage of marks, and we need to plot a normal curve and check. We need to check whether that is normal or there is some kind of deviation in the normality. Okay, because as the number of observations are only 14, probably we may not get exact normality of the curve, because in the last case I have purposefully given the data which is exactly same distant both the sides from the mean. Purposefully have created a data set like that. If you see, as mean is 216, -2 + 2, -4 + 4, -6 + 6. So I've taken care to get a normal curve. But here, as marks of the students, we cannot get, and that too, it is a percentage. Okay, is percentage a discrete value or a continuous value? It's a question to test your presence of mind. Is percentage of marks is discrete value or continuous value?
It will be continuous, sir, because 0 to 100, any of the percentage value can come.
So Varsha is feeling that it is continuous because 0 to 100, any value can come. Any other opinion, or all the 3 people are feeling the same? Because Varsha is feeling it is continuous. Is it continuous or discrete? Any person is differing from Varsha's opinion?
Sir, it's discrete.
Discrete. I've mentioned percentage and I've shown the values also here. Is it discrete or continuous? And Varsha has got some justification, as it can take any value between 0 and 100, it is continuous. And Swati is feeling it is discrete. What is justification for that? Why do you feel it is discrete? And what do you mean by discrete? Yes, Swati, any justification, or why do you think it is discrete value, percentage of marks?
Because it's not part of a score interval. But since you mentioned percentage, now I'm thinking.
Okay, so it is 87.8, 867.8. I said discrete values can be counted, and percentage, continuous values will be measured. So, and the other simple heuristic that you can remember is if you have something called as percentage points, decimal points, then it falls in the category of continuous data point only. Okay. So as one of the justifications is as it can take from 0 to 100 any value, and we cannot confine like 87.8 or 87.82, or if you take percentile or something 88.932. So we cannot confine a particular value. We cannot count it. It will be measured. So it is a continuous value. Fine. Is that clear, Swati? It is a continuous value.
Yes, sir.
And the justification is simply like this. Like, since it is some kind of simple decimal value, we call it as it falls into category of continuous. Okay. So now, and one more thing about normal distribution is, one of other things of normal distribution is, I said mean, median, and mode should be equal. If they are equal, then you call it as a normal curve. If they are not equal, then we cannot call it as a normal curve or normal distribution. Okay. Now we have got 14 students max. We'll see how far they are normal or not. Okay. So we'll just see the students' normal curve. Okay. And these are the marks of the students, right? So I'll take one more sheet. So these are marks of the students. Since you already know how to calculate mean, median, mode, variance, standard deviation, so this time I'm not taking that much of time for finding that one. Mean is simply found out using average of these values, right? So I just found out average of these values. The first step is finding mean, because any normal curve. So if you are talking about normal curve, you have to find mean and variance. And as we'll be comparing with standard deviation, we have to find out first step is mean. The second step is standard deviation. These two should be found out always. Okay. So as mean is something 69.67 something, and standard deviation. So standard deviation will be found out using STD. There are two things. So STD-EV.P and STD-EV.S. Okay. So if I just try to find out this value, it assumes that my total values are in population. Okay. So this gives me standard deviation, assuming it as a population. And if you are dealing with sample data, so for the sample data will be found out using STD-EV.S. Okay. But in this case, as we'll be just trying to find out with a difference of each and every value, I am assuming it has to be a population. Okay. Though it is a sample data, since I'll be comparing mean with each and every observation, I am assuming it as a population. Okay. I hope you know how I found out this value, like standard deviation. So if you want to see what formula that I have used or what command I have given for this one, you can simply use formula text this value. This will give you like what formula I have used here, right? Whether I've used population or standard deviation, STD-EV.P or sample. If you use the same thing here, formula text of this value, it will simply show that standard deviation of a sample data. Same data, but here I have found out with population. Here I have found out with sample. Okay. Since I'll be comparing all the values with mean, I am assuming it as population thing only, right? So next step, like what exactly we did in the last case is we have arranged that in order. Okay. So just I'm arranging this from smallest value to largest value. Okay. I hope you are following, right? This time I have not found standard deviation by using this sort of deviation, this something like that. Straight away I'm following, I have calculated using the formula, right? And now I'll be finding the normal distance. Normal distance is, so norm distance of this particular value, comma, what is my mean? I have calculated mean as 16 point something like that. Okay, so I'll be fixing that value because I have to compare 51.2 data with 69.6, 51.4 with 16.6, something like that. Okay, and my standard deviation. So I have taken the standard deviation. As I want to find out probability mass function, I'll make it as 0, false. Okay, I'm not finding a cumulative value. I have to find out each and every individual mass function. Okay, so this has given me 0.01 something. Okay, if I just drag that to the last, I'll be getting some values. Fine. And once I found out these values, I'll be just finding these things. I have to insert a graph, so which deals about the normal curve. Okay, so this is what my tentative normal curve. So here, when you see a curve like this, because in this thing, the left side, the total data is left out. You can just simply format the axis, and in the minimum value, as it is starting from 50 something, maybe you can call it as 45, and you can just take your figure like this. Okay, now you can see some kind of normality. Okay, so as I told, what is the relation of mean, median, and mode in normality, normal distribution or normal curve? How will be these three values? What is the relation between mean, median, mode when it is a normal curve?
All will be at the same point.
All will be at the same point or equal value, right? Okay, now we'll see what exactly as mean is simply average of these values. So from here to here, mean. Okay, so median, there is a formula like even if you just see here, so this is what the total number of observations. How many number of observations are there? 14. How can you find out median with 14 observations? You have to find out the middle value. Okay, so it is n plus 1 by 2, n plus 3 by 2. So it will come between. So if you take 5 here, this value, if you take 1, 2, 3, 4, 5 here, so you can take 6th also. So 6th value, 6th value. So median is simply average value between these two. Okay, if you just go manually or procedurally. Apart from that, there is a function median which gives you the total median value. Okay, so this is what median value. Even if you just take average of these two, so sum of these two divided by 2, you'll be getting the same value. Okay, so either you go by manual method or the functional method, you'll be getting the same thing. Okay, how do you get mode of any data?
Frequency, which is repeating.
Which is repeating, or any maximum time of occurrences. In this, which has occurred maximum times? There is no repetition, right? Because 51.2, 51.4, 54.4, 60, 61, 66, 67.8, 72.8. So there is no repetition. So in that case, if you try to find out the formula of mode, so mode of these values, you will get some kind of error. So this is non-availability of data or not applicable something. So under these circumstances, you can find out mode, which is called as forced mode. So usually that is called as forced mode. How do you find out forced mode? So 3 into median value minus 2 into mean value will give us the forced mode. Okay, so this is called as forced mode, right? When there is no repetition of the data, or when the data points are not occurring multiple times, so then we'll go for some kind of forced mode, which will be found out using. So this is this particular value. So 3 median minus 2 mean. So that is the formula to find out a forced mode. Okay. Now, if you see, can you infer anything from this? Is it a normal curve or any problem or any deviation in these things? Do you think is it a normal? Because our mean is, I'm just making somewhat bigger so that you can see, my mean is 69 point something, median is 70 point something, mode is 71.5 something. Is it normally distributed or any deviation is there?
Sir, if we round off this mean, it will come around 70.
Yes.
Median also comes around 70.
Fine.
Yeah, forced mode is a digit more. 71, 172 it will come if we round off.
Yes. So in that case, these three entities are not same, right?
Yes.
So this concept has led to concept called as skewness. Okay. If these three entities are same, then we can feel that the data is normally distributed. In the previous example, I'll try to show in the previous example, which I found here. So my mean, median, mode. Okay. So here, if I want to find out mean, it is simply average value of these things. If I just find out that one, it is coming to 216. Already we have calculated. If you want to find out median value of these things, it is coming to 216. If I try to find out mode, again, as there is no repetition here, I'll get some error value. If I just find out the forced mode, so it is going to be 3 multiplied by median minus 2 multiplied by mean. It is 216. So in this case, is the curve normal or not normal? Because my mean is 216, median is 216, mode, the forced mean is 216. So as all the three entities are same, I got the normality, or I can see a normality here. But in this case, if you see in this case, my mean is something, median is something, mode is something. Okay. So this has led to a concept called as skewness, because there is no, these three entities are not same. Okay. So that is what my interpretation here. Because in the problem, they have asked you to find out mean, median, mode. But if I just found out mean, median, mode, it is not showing some kind of normality. Okay. So that has led to the concept called as skewness. Okay. So is that clear? Or do you want me to explain one more time or one more problem? In the next class, definitely we'll see what is skewness and what is kurtosis. But apart from that, if you have any doubts, you can ask me so that I'll try to explain the concept one more time. Because normality is something which has got unimodal, and mean is going to be 0, and standard deviation is going to be almost 1. Okay. And if there is any deviation among mean, median, mode, so then that concept is not, that distribution is not satisfying the normality aspects, so which has led something called as skewness. Okay. So there is one more example of heights of the students, okay, in centimeters. I'll just quickly show that one. I think this is somewhat. So this is somewhat the production of the data, the diameter, height. Okay, the same thing. I hope you can see the screen, right? There are different heights of different people. The student name, I have sorted that values, and I found the normal distribution, and I've calculated this value. Okay, so in this case, I found median as 168.2. So mean as 168.2, median as 168, and mode as 155. As there is some kind of repetition here, I think I got, there is a repetition here of 155. So I got these values straightly. Is that clear?
Yes.
So even in this case, there is a difference here. Okay, so forget about the skewness something. So if you are okay with this, so then I'll go to the next thing. So this is what skewness, and I'll just introduce the topic and we'll see some other thing in next class. Okay, and skewness, as you can see, if skewness is used to measure the level of symmetry, as we have seen something called as symmetrical. If it is if the median is dividing the total data, if the mean is dividing the total data into two equal halves, so then we can call it as a symmetrical curve, 50% here, 50% here. If that is not doing like that, so you can see something here where mean is here, median is here, mode is here. In this case, mean is here, median is here, mode is here. So under such circumstances, you call something called as skewness. So that we'll see in the next class. Fine. So any doubts so far in normality curve and the examples which I have discussed? If any doubts, you can ask me. I'm open for queries for a couple of minutes. So the skewness and kurtosis we'll see in the next class. And area estimation also. Any doubts? I hope you might have you might have come across a person called as Eliyahu Goldratt. So there is a person called as Eliyahu Goldratt. Right? RPRIT. He has written a theory called as theory of constraints. I hope you might have seen this constraints. And he has mentioned something called as student syndrome. If you find time, you just go through that one. It is very good, especially for the teachers. Eliyahu Goldratt, theory of constraint, and he has mentioned something called as student syndrome. So even if a faculty becomes a student, how the phenomena or how he or she takes the class or answers the thing. So student syndrome. So try to observe that one. So that will be very good for your teaching field. Okay, fine. So, sir, that's what from my side. Anything, sir? Ma'am, Farah ma'am, is that fine? Can I assume that the session is done for today?
Yes, sir. Swati, Varsha, Mona Lisa, any doubt, any feedback you want to give it to sir?
Sir, it was a good class, sir.
Thank you. No, if you at all anyone has got out, definitely you can approach me or Farah ma'am also, not a problem. Okay.
Swati, how are you liking it?
I am liking it quite a lot because sir has been illustrating it with a lot of examples. He keeps going back to an Excel sheet and explains it with multiple examples, not just one actually. So it's good. It's going a bit fast, but it's not like we're not able to catch up with it. So yeah, I'm enjoying the classes actually.
Yeah,
Thank you, Swati. Thank you, Varsha. Okay, sir. Then we can close the session.
Yeah, good night. So good night, sir. Thank you. Bye.
Thank you, sir.
Yeah, thank you.